together partnering to, and with Trent University, to do some research on calcium deficiency in the forest. He'll explain the whole thing, but anyway, I'd like to welcome Norman. Norman's was 25 years in the Ontario. I can list everything off. Anyway, he's worked. He was a professor at York University. He's co-authored over 200 productions on Canadian lakes. His work has been cited over 10,000 times. He's won the K. Patalis Award for Research Excellence. He's won the F.H. Wriggler Memorial Award from the Society of Canadian Limnology, which is the study of lakes. He's received the Premier's Research Excellence Fund Award. He's got visiting fellowships from the Australian and Italian governments. I could go on, there's a lot there. But Norman's here in the capacity to, as he's the former chair of the Friends of Muskoka Watershed, one of the founders of that organization, and now head of the environmental committee, which is basically the driving force between all the work that gets done, including the work at the camp. And we've also become a pretty good friend of mine. So without further ado, I'd like to welcome Norman Yan to the.
Well, thank you, Doug. My mother would have been thrilled with that introduction. Now I just have to figure out if I can share my screen here. Okay. So I think I can do. Can you all see that? Okay, I know you can't. Okay, so it's my job and my pleasure and my honor over the next 40 minutes or so to tell you what the Friends of the Muskoka Watershed are doing to try and deal with one of the most serious threats to the watershed, which is calcium decline. And I've got this nice title, From Fireplace to Pancakes, and you'll see as the talk goes on where that title comes from. And you'll also see how this work couldn't really be done well without the help of Camp Big Canoe. So let's get right into it. So let me start, as most speakers should, just by thanking people. So the Ontario Trillium Foundation has provided the funding for this talk. There's a lot of people in Muskoka that are sharing their ash with us. I'm told by Tim that it's now over 800 people.
Wow.
Sean Watma has contributed, or there's about 6 students, 5 graduate students and 1 undergraduate student from Sean Watma's lab that are working with us on this project, half of them at Camp Big Canoe. We couldn't be doing this work also without the help of Sugar Bushes. So Ken Riley, Mark Lupton, Will Creaser, their Sugar Bushes staff, and Tim, Paul, and Chris from the Friends of the Muskoka Watershed, and Doug, who you all know very well, who's the Friends of the Muskoka Watershed Board and our very able vice chair, and actually the project manager for Ash Muskoka. And you, of course, know him as a driving force at Camp Big Canoe. With that out of the way, let me introduce this talk with the term osteoporosis that you will all know well. I didn't see all the heads in the screen, but if there are a lot of white heads like mine, chances are there are a few people with osteoporosis in this crowd, because 1/3 of women in Canada that are seniors and 1/5 of men suffer from osteoporosis. So there's about 1.5 million osteoporosis sufferers in Canada. Now, unless you're medical doctors, and I'm not, I mean, I don't know the details of osteoporosis, its cause, but we certainly all have a sense that it's linked to failure in calcium metabolism. We're either losing calcium more than we should, or we're not able to take it up. And so that weakens our bones and makes us more vulnerable, of course, to injury. Now, calcium is incredibly important to us, not just for our bones, but also for nerve and muscle function. Our muscles wouldn't contract, nor would our nerves fire without adequate supplies of calcium. So it makes some sense to consider where this calcium comes from, and to ask the question, might the entire landscape in some situations suffer from acute calcium lack? So calcium moves through our watershed, generally moving downstream. And over millions of years, it all ends up in the ocean and then gets taken up by mollusks and forms the Great Cliffs of Dover after the White Cliffs of Dover after they are erupted. We're more interested in scales of thousands of years or even tens of years, not millions of years. And over those smaller time scales, we look more at phenomena that you see in this graph. Calcium enters our watersheds and our landscapes by mineralization of rocks down here below the forest floor. And it also comes in rain and dust. And so if there's less rain and dust fall, calcium, less calcium coming from mineralization of rocks, there will be less calcium available to the biota. And if some mechanism like acid rain, for example, increases the leaching of calcium from the soil, we can be in a situation where the losses of calcium greatly exceed the supply, and then whole watersheds might be in trouble. So we could ask the question, might whole watersheds suffer from the ecological equivalent of human osteoporosis, something we might call ecological osteoporosis? And we're going to consider that question now. If soil and water calcium levels fall below the levels needed by biota, it would be like us not eating enough food with calcium in it. We can expect living systems to suffer, and the animals that need the most calcium will suffer first. So what are those animals? So here's us over here. We are 6% calcium if we forget all the water in our bodies. And many other animals that live in our lakes initially need more calcium than that. It won't surprise you that it's the crusty animals. Crayfish can be up to 30% calcium, mollusks 30% calcium. Turtles with their amazing rib cages that have turned into a shell are 15% calcium. Even though fish are buoyed up by the water, some of them, like bass, are 8% calcium. Trout are only 2% calcium. But the bass have calcium in their bones, but all of their scales are also calcified. So even some fish can need more calcium than us. I spent most of my life working on little animal plankton. This is a little relative of a lobster called a daphnia. And there's 10 of them in every liter of healthy lake water in Muskoka. They're all gals. They've given up on men for most of the time. It's kind of a waste of time. And they're 5% calcium, and we need them. The entire volume of Heart Lake on which the camp sits is filtered through the stomachs of Daphnia every week in the summer.
Daphnia.
So let's first ask the question, are calcium levels stable or are they falling? We are very lucky in Muskoka to have one of the world's foremost limnology research centers, called the Dorset Environmental Science Center, run by the Ministry of the Environment, Conservation and Parks. Andrew Patterson works there, and he shared these calcium data with me from their 7 main study lakes. Since just before 1980, they've been sampling 7 lakes every 2 weeks or a month in exactly the same way. And you see this remarkable pattern of almost a 40% calcium decline in lakes over that time period. Now, the absolute decline is large and clear, but it's not this percentage that matters. It's the actual level of calcium in the water. So here you'll recognize a water. Here's Ontario. Here's the Muskoka watershed. Here it is blown up. Here's Lake Muskoka, Georgian Bay here, Algonquin Park over here. We being the government and all kinds of academics have sampled close to 500 or 600 lakes in the watershed, about a third of all the lakes. And every red dot, red triangle or red circle, is a lake with calcium less than 2 milligrams per liter. Half the lakes in the watershed now have less than 2 milligrams per liter, and that is a level at which calcium-rich animals start dying. Those animals are suffering from osteoporosis. So what about Heart Lake? Well, this is a picture of Ron Ingram. He's probably the best limnology technician in Central Ontario. He just retired after a great career, 30 years of work with the Ministry of the Environment, sampling lakes every single day. And he's agreed to volunteer to sample Heart Lake as often as we want him to. So I accompanied him last summer, and this is me holding the camera while he's doing the work. This is measuring temperature and oxygen. This is taking water that's been collected in this graph. And the Ministry of the Environment at Dorset has one of the best water quality labs in Ontario, and they've agreed to provide analytical support for this work. So I'll just tell you a few things about what Heart Lake looked like last year. The pH was 6.8. That's as close to circumneutral as soft water lakes get. This lake is not suffering from acid rain from an acidity standpoint. And this value here of alkalinity, 5.9, means it's got some buffering capacity. So it can withstand a little bit of acid input. This just means the lake is colored. No more, that's completely natural. I was very pleased to see these chloride and sodium levels. And this means Heart Lake does not have a road salt problem. Road salt levels vary by almost 700-fold among lakes in Muskoka, but chloride of 0.33, that's close to the lowest that chloride levels get in any Muskoka lake. So here then is the only problem. The measured calcium level last summer was 1.4 milligrams per liter. Below 1.5 milligrams per liter, calcium-rich animals start dying. So the only water quality problem that Heart Lake has right now is low calcium. Maybe there's something we can do about that. If calcium levels in the lake are low, lakes get their calcium from the air, dust and rainfall from the air, but mainly overland flow from the watershed. If calcium levels are low in the lake, it probably means calcium levels are low in the watershed. So let's crawl out of the lake up to the watershed and ask if crayfish and daphnia are the sensitive animals in lakes, what are the sensitive plants in a watershed? And it would be the plants that have the highest calcium demand. So let's compare maple and birch and a conifer. This is calcium levels in the wood. Maple have 3 times more calcium in the wood than birch, and 5 times more than conifers. The bark has 10 times more calcium than birch or conifers. And even the leaves, where all the calcium is not structural, it's more metabolic. The hardwoods have the same, but more than the softwoods. So if there's a tree that we would suspect would be in trouble because of low calcium in the soil, it would be sugar maple or any of the maples. So have calcium levels been declining in the soil? Well, this is where it's good to be working with Dr. Watma at Trent University. Last week, he had a student submit a PhD thesis that looked at a model for 150 or close to 200 years of declining levels of calcium, magnesium, potassium, and sodium in the soil in sugar bushes in Haliburton. And what that study predicted, sort of hindcasted, was that there'd been a 40% decline in calcium since 1850. Now, if you think about it, you know, this forest would have emerged out of glacial, out of the ice 6, 7, or 8,000 years ago. And for the previous several thousand years, the forest has grown fairly well there. But just in this blink of time, the last 100 years or so, there's been this dramatic decline in calcium in the watershed in Haliburton. And that pattern is typical of Central Ontario. So starting in the early 80s, what was then the Ministry of the Environment's Air Resources Branch identified about 3,500 hectare woodlots. And each of these dots is one of these 100 hectare woodlots. And every year they sent a crew out and they assessed the health of that forest. They looked at canopy cover, dead branches, incremental growth, wood accumulation, and they looked at the soil chemistry and the foliar chemistry, the chemistry of the leaves. And they found between 1985 and 2005, a 60% decline in calcium levels in the soil. And that was associated with about a 20% decline in calcium levels in the leaves. Now that's an average for all of Ontario, and the numbers were a little higher in Halliburton, Muskoka, Nipissing, Parry Sound. They also looked at all the metrics and classified the forests as either unhealthy or healthy. You know, how thick was the canopy? Was there tip dieback? That kind of thing. And they found that the forest woodlots where the sugar maple were classified as unhealthy had lower calcium in the soil, that's that difference there, and lower calcium in the leaves. So calcium levels have fallen in soils, fallen in leaves, and the trees are unhealthy because of it. These trees have arboreal osteoporosis, if you like. So why are the soil calcium banks shrinking? We can actually use an automatic banking machine metaphor here with some accuracy. We all know that the amount of money we have in the bank is a function of what we put in and what we take out, and maybe what our grandparents got us started with, you know, when we were young. Well, the glacial history are the grandparents here. So the glaciers either deposited soil in watersheds or took it away. And in Muskoka, they mainly took it away. The next deposit of calcium would come from what type of rock is it? If it's limestone, it's 40% calcium. But if it's granite, there isn't much calcium, and it's hard to get that calcium out of the granite. So if you have thin soil underlain by granite that weathers slowly, you're not going to have a lot of calcium, especially if dust and rainfall inputs of calcium are falling. And they actually have been falling over the last 30 years as we've cleaned up pollution. The last possible source or deposit to the calcium bank is what we do. So we add dust suppressants to roads, for example, and fertilize our lawns, and potentially add wood ash. And all of those human sources for Lake Muskoka, for example, have balanced the natural losses. So calcium levels in Lake Muskoka are not actually declining, even though calcium levels in 50% of the watershed are. There also are mechanisms where calcium is removed from the soil bank. Natural acid leaching, as trees grow, they pull calcium out of the soil. The trees are about 0.5% calcium, for example. If the tree just dies, that calcium is not lost to the watershed. But if the tree is removed by logging, then that's a net loss of calcium from the watershed. And the biggie, acid rain. Acid rain has been the big driver. Acid deposition rates have been greater than natural weathering rates of rock. Inevitably, that means calcium levels have been stripped out of the soil. And actually, we've lost, as you saw in that graph from Dr. Watwa's lab, about 0.5 ton of calcium per hectare over the last several hundred years. So that now gets us to the work we're going to do here. So Doug and I are on the board of the Friends of the Muskoka Watershed, and it has a vision of keeping Muskoka watersheds healthy forever. And we execute that vision with an overtly scientific bent. We work with the local community, and we have great scientists locally in the district and at the Dorset Environmental Science Center. And then we keep track of the work that the scientific community is doing more broadly to help us identify widespread stressors in the watershed that aren't being dealt with, like calcium decline. And then we try and develop and foster solutions that could involve the local community. I'll take a slight detour here and tell you that I've been in the environmental science game for 50 years, and I still am optimistic about dealing with environmental problems. And that's because in the 60s, we were dealing with acid rain, DDT and the loss of songbirds, lead pollution from gasoline, and the first reported death of the Great Lakes. All of those were the founding environmental issues of the 60s. And initially, they were all thought of as insoluble or too difficult to deal with. And we more or less solved them all. And reflecting on that, it's my opinion that it takes only time and knowledge of what to do and the will to do it to solve environmental problems. And that knowledge is a function of humility, because humility keeps your mind open. We have to recognize we often make mistakes. Individually, we're kind of dumb, but collectively, hopefully, we're smart enough to create and use the knowledge. And of course, hope. You know, we can't do anything unless we're well, let's just say that despair is no platform from which to solve any problem. So how does the Friends of the Muskoka Watershed create the knowledge and the will that can actually help solve environmental problems? Well, we do it simply like this. We start by tracking the key watershed threats or problems that share three characteristics. They're widespread and severe. They're not being dealt with currently by the government. And the local residents of Muskoka can play some role in their solution. I'm just messing a bit here with, okay. Then we identify gaps in knowledge needed to solve those problems. Once we've identified those gaps, we usually need to raise a little money because we're going to work with academics to plug those knowledge gaps. And once they're plugged, we will work with the communities, be they local residents or the government or whoever, to help solve those problems. How does that actually play out with this particular problem of acid rain? Acid rain that caused calcium decline, widespread calcium decline or ecological osteoporosis. I hope I've convinced you that calcium decline is a problem. It affects half the lakes in the watershed. It affects the forests in the watershed. It's widespread. It's not being dealt with by governments. The governments dealt with acid rain, which was great, but they're not going to help us at the moment, or they didn't have a program in place to add the missing calcium. So we, the Friends of the Muskoka Watershed, selected calcium decline as the first issue we were going to tackle. So what do we need? What new knowledge is needed? I've listed a bunch of questions here. Is wood ash a good source of calcium? How much of it do we need? Is there enough of it to make a difference here and around? Are there any risks? Turns out the ministry is very worried about toxic metals, for example. Can we prove there are benefits? Those are all environmental science questions which graduate students, for example, in Chomp Maltma's lab at Trent, can address. Then there are kind of some psychological questions. Will the public share their ash? There are kind of logistic or engineering questions. How do we add it? And then big regulatory questions. So we felt to move forward to solve this problem, we had to answer these questions. We got 2 grants from the Ontario Trillium Foundation, struck partnerships with 3 universities to help us answer these questions. And I'm going to summarize some of that work today. And then ultimately, when we have all the answers, we hope we can get forest managers, policymakers to execute the solutions that we're going to talk about. I'll introduce it now. It's going to be called the 2-ton challenge. We want to add 2 tons of wood ash to all the forests that need it in Muskoka. Okay, so let me try and convince you what a difference this could make. I'm going to give 2 examples. One is at the remarkable Hubbard Brook Experimental Forest in the White Mountains of New Hampshire. This is an area that received roughly the same amount of acid rain that we did here in Muskoka for roughly the same period of time. And they've been studying the health of that forest, they being a whole bunch of academics, for I think about 60 years now. And they came, and that's where acid rain was discovered in North America, was in the Hubbard Brook Experimental Forest. And they figured their forest had lost 0.8 tons of calcium per hectare. So they picked a whole watershed and they added that much calcium in the form of calcium silicate and got all kinds of students and academics together to track the results they did the addition in 1999, they followed it for 5 years. This bar graph shows what happened to calcium levels in the leaves. So calcium levels in the leaves within a couple of years increased by 50%, within 3 years by over 100%. So soil pH went up, chlorophyll level and calcium levels in the leaves went up. And that allowed photosynthesis rates to go up substantially, which means more carbon was captured, more oxygen was generated, more carbohydrate was generated, more wood was generated. The thing that most shocked them was transpiration rates went up. The whole forest woke up. It had and pumped more water. So the stream The transpiration rates went up by 25%, and the stream and the watershed actually dried up for the first time in 50 years. The whole forest had been limited metabolically, physiologically, economically, dynamically, hydrologically by low calcium, and adding the calcium that had been stripped away by acid rain made all of these differences. We don't have to go as far as New Hampshire. We could just go over to Halliburton, where Sean Watma and a number of others in 2014 added some industrial wood ash in the Halliburton forest, and they use either bottom ash or fly ash, and they added either at 4 tons per hectare and 8 tons per hectare, more than I think we need. But within 2 years, these are calcium levels in the leaves, had gone up by over 50%, from below a critical level at which calcium was limiting photosynthesis and metabolism to above that level. So we're fairly confident adding ash will work. With that in mind, we launched the Ash Muskoka project and got funding for it from the Ontario Trillium Foundation. And that foundation doesn't have much interest in funding research per se. Trillium funds public engagement in good work in society, usually social work, educational work, but also environmental protection work. So our first goal is to encourage public engagement in environmental protection by developing Canada's first non-industrial wood ash, or mainly residential wood ash, recycling program that's designed to solve this widespread problem of calcium decline. And in the meantime, there's a bunch of applied science has to be done so we can do this. You know, how much wood ash do we need? We need to prove it works. We need to figure out how to get it approved, how to get people involved, and that kind of thing. So I'll just briefly introduce you to what we're doing. So we have 9 kind of corporate partners. They're listed here. The Ontario Maple Syrup Producers Association had independently determined that there was an enormous calcium decline problem in their forests. So they were very keen to work with us. The district government has been enormously helpful from the standpoint of collecting ash. The Dorset Environmental Science Center was critically important in the first year. We did a whole summer of work on the chemistry of ash and the toxicity of ash. There were 3 universities involved. I'll tell you about them in a sec. The Steamship and Discovery Center is helping us with public outreach. West Wind will eventually help us in applying the methods on Crown land. And I'll tell you in a few minutes what Camp Big Canoe is doing. Here are the academics that are involved. I'll start over here with Dr. Chantal Berriot. She runs the Science Communication Master's Program at Laurentian. An intern from her shop worked with us for a whole summer to make a video, which we use for marketing. Bob Gifford is an environmental psychologist at the University of Victoria. I must thank Trillium for allowing us to send a little money outside of Ontario, which they don't normally do. Bob Gifford is Canada's premier environmental psychologist, and he's helping us understand the motivation of will for getting people to share their ash with us. But the main recipient of our funding largesse is Dr. Sean Watma at Trent University, a wonderful forest biogeochemist, probably Canada's expert on the effects of calcium decline on trees. And we're funding a number of graduate student projects in his lab, and I've just listed what some of their focuses are here. How much ash is needed, what are the risks for the trees, the benefits for the trees, how available is the calcium in the ash. We've just started a project on maple sap production in his lab, and then a master's student in environmental policy, and that'll be very important to us down the road. The most important contributors, though, are everyone else, the hundreds of people. Won't it be nice when we can gather like this again, hopefully by the end of the summer, hundreds of people that are sharing their ash with us. Okay, a little bit of science. What's the chemistry of wood ash? So we started by saying, well, there's no point using this ash unless there's very little variability between sources and there's a lot of calcium. So we initially worked with 10 people that shared their ash with us. And these little bar graphs or box plots are the levels of calcium, potassium, magnesium, sodium, and phosphorus in these samples of ash. This is the key one. 30% of the ash is calcium, and there's very little variation between suppliers of the ash. So that's almost as good as pure calcium carbonate. Pure calcium carbonate is 40% calcium. Wood ash, once you screen out the char, is 30% calcium. I apologize, this is my most complicated graph. So if there's a chemist in the crowd, this is for you. The Ministry of the Environment, Conservation and Parks is very worried about contaminating the landscape with what they initially considered to be not a fertilizer, which is what we consider the ash to be. Everything in it came from the soil, came from the trees. We're just putting it back where it came from. But they consider it initially a potentially risky waste. So they wanted us to measure the arsenic, cadmium, chromium, cobalt, copper, lead, mercury, molybdenum, nickel, selenium, and zinc in the ash. And so we did that. And I want you to see that none of the levels in non-industrial wood ash are coded blue. So nothing has levels high enough, higher than in this column, which they would consider an industrial waste that we'd have to landfill. And a couple are maybe slightly problematic. So if the level in your ash is above what they call their CM1 target, then they just want to make sure that you're not adding enough that it's going to show up in the groundwater or in the plants. And so when they saw our levels here, the Ministry of the Environment, Conservation and Parks have approved our additions, but we would continue to measure the chemistry of the ash in the future. What I want you to point out is I'm comparing our non-industrial wood ash with a compilation of industrial wood ash that the federal government has put together in a project called AshNet. And in almost every case, the levels of metals in Muskoka residential wood ash is much lower than in industrial wood ash. Sometimes 100-fold lower, like the chromium levels were 100-fold lower, but typically 10 times lower. And so we're producing very clean ash here in Muskoka, which the ministry is happy to have us use. So what are we doing? We're securing the approvals, which is non-trivial, working in 3 sugar bushes to determine effective ash doses and testing risks and benefits. In a sugar bush, which is not a natural forest, easier to work in, simpler environment. Then we're moving to a real forest, the real forest at Camp Big Canoe, using larger additions of ash, and I'll come to that in a minute. And then if all this goes well, communicating the benefits and then fostering ash recycling programs across Muskoka. I'd like to tell you that it's working. Here are 4 of 800 people that have come to our office and collected cans that they're then going to fill with ash from their fireplaces or wood stoves. Thanks to Gravenhurst Timber Mart and Mama Bears who are helping us with these collections. Chocolate Margaret from Mama Bears washed thousands of empty ice cream buckets before she gave them to us. People are then bringing their ash to Rosewarren. Here I am with some staff and the deputy mayor and another member of the board and staff collecting ash. And then we screen that ash. So here are 2 very happy members of our board, Dr. Neil Hutchinson and Peter Kelly, our current chair, at our December ash drive, which was the last one we were allowed to have. So we screen all the ash to remove the char and then run big magnets through it to eliminate the metals and make sure it's cool. We haven't burned down the site yet, but we've had a number of occasions where people have brought us hot ash, so we don't like that unless it's February, and then we toast marshmallows on the hot ash. Then after the ash was screened, cooled, analyzed, approved by the Ministry of the Environment, Conservation and Parks, we trucked it This is about a ton of ash being trucked to Ken Riley's sugar bush. Then with the help of lots of volunteers, we weighed it out into these 5-gallon pails, 10 kilograms of ash per pail, carried it into the bush. This is Ken Riley's bush. This is Will Creaser's bush. I'll just point out this young lady, Batul, I'm about to show some of her data. These are 3 graduate students from Trent University here. Then we spread the ash on pre-measured plots. This is what 8 tons of ash per hectare looks like, spread on top of the maples. And I'm going to show you 2 data plots. So the Trent University students are doing an enormous amount of work. They have collected in the 3 sugar bushes, I think it's over 600 soil samples. So they collected soil from 3 layers at 5 locations at those 3 depths, from 5 replicates at 3 treatments, control 4 ton and 8 ton per hectare, in 3 sugar bushes. So I've collapsed all of that data on pH into these 9 numbers. So these plots, the soil was very, very acidic. When the sugar bush operators realized how acidic their soil was, they were not happy. And the soil agronomists they worked with had actually told them they had to lime all of their forests if they were going to have a successful bush there. So the addition of 4 and 8 tons per hectare, for those of you that understand pH and remember pH from high school, it's a log scale. So going from 4.5 to 5.5 to 6.5 or 6.7 is a 100-fold reduction in acidity at the 4-ton dose, and even more than that at the 8-ton dose. And in the humus layer of the soil, again, an enormous reduction in acidity, 100-fold in the 8-ton dose. And even though this doesn't look like much, given that this is a log scale and it takes a while for the calcium to get through the soil, these are also big reductions in acidity. But our goal was calcium, not acidity. So what's happening to the calcium? Again, I'm reducing a huge amount of data into one very simple bar chart. And this is just on seedlings, and this was after 1 year. We don't have the data for the mature trees yet. I hope to have it later this week when Batul is having her first committee meeting at Trent, and I'm on her committee. A 50% increase in calcium levels in maple seedlings. What might that mean for photosynthesis, for carbohydrate production, for transpiration? 100% increase in calcium levels in the stems, in the shoots of the seedlings. Calcium does for trunks of trees what calcium does in our bones. It makes them stronger. It binds the filaments together. And 170% increase in calcium levels in the roots. So enormous benefits for the element that was limiting the health of sugar maple at the sugar bushes. So what might this mean? I'll just list these things again. More chlorophyll, more photosynthesis, which means more carbohydrate production, more carbon capture, more transpiration, which might have implications for flooding, stronger wood, because there's more calcium to bind the cells together, particularly right under the canopy. That's where trees need the most strength, just at the top of the trunk before the canopy opens up. All of these benefits we hope to see with the addition of ash. So let's bring in Camp Big Canoe now. The next step was to move from this kind of controlled sugar bush to a more natural forest. And Doug encouraged us brilliantly to consider the forest at Camp Big Canoe. We considered 4 other possible sites, but settled on Camp Big Canoe. And we didn't yet have the result of the 4 and 8 ton treatment, so we went in between in plots that were individually 16 times larger than the plots in the sugar bushes. We added 6 tons of ash last November. Now, what do we expect to see? This is the calcium level, 271 milligrams per kilogram, in the soil at Camp Big Canoe. It's kind of in the middle of the 3 sugar bushes. The Brooklyn farm is Ken Riley's bush that I just talked about, and that's the farm where the agronomist said the calcium levels are so low in the soil that that forest is in real trouble. Right now, I believe the health of the trees at Camp Big Canoe are in trouble because the calcium levels in the soil are so low. You will have all seen this aerial photo at some point of Camp Big Canoe and its watershed. We marked out 8 quadrats and then randomly chose quadrats 1, 4, 7, and 3 to get the 6 ton per hectare ash addition. If you can see this red line on the aerial photo, that's the whole area that we're currently legally allowed to add ash to the watershed. The only place we won't add it is to these yellow plots because those are the controls. So where are we going? We're going to be doing a 2 ton per hectare dose at the camp this spring in just a month or two. That will give us 2, 4, 6, and 8 ton doses that we can compare, but we've pretty well settled on 2 tons is really what's needed. 2 tons should replace all the calcium lost to acid rain and then some, and get the calcium levels in the forest back to where they were 200 years ago. We're going to, of course, write this all up, but we've learned enough about the benefits of calcium additions that we have a couple of things we want to do in the future, and this will depend on additional funding. We want to demonstrate, and we think this is true, that adding ash will increase carbon capture. In fact, across Muskoka, increase carbon capture by, or CO2 capture by hundreds of thousands of tons if we could ever add the ash to the whole watershed. Mitigate wind damage because calcium, if the trees have more calcium, they'll be stronger. There might even be an influence on floods because trees that are not calcium limited pump more water. And the one thing we're fairly confident of is that there'll be more production of maple sap, hence my title. This is, if you walk through the bush at Camp Big Canoe right now, you'll see this. On the treated and untreated plots, we have a number of buckets out, and we're tapping the trees and collecting the sap. And that's being analyzed at Trent University by one of Dr. Waba's students. And then we hope to plan and launch what we're calling the 2 ton challenge. So let me reassure you that we are hoping there'll be more maple syrup. Roch Wame's lab in Quebec has just published this paper that increasing calcium levels improves the characteristics of sugar maple over the long term. So that's good. What is this 2 ton challenge? Well, it's kind of a dream of how to fix the Muskoka forests and protect them from climate change over the next 30 years. The district has just adopted a plan to be carbon neutral by 2050. So we have 30 years to sort this out. 25% of all of the carbon emissions in Muskoka could be sequestered if our forests were not as calcium limited as they currently are. So while we initially were just thinking of fixing this calcium decline problem, we now think this addition of ash might have all kinds of extra benefits that need to be quantified, and I'm listing them all here. Increased resilience to wind damage, sequestering more carbon, potentially reduced risk of spring floods, etc., etc. What role might Camp Big Canoe play in all this? So this is what we're currently doing at the camp. With our staff helping Sean Watma's students. So with the ash additions we've done and we'll be doing in a few weeks, hopefully showing the benefits of ash additions for the growth of a number of trees and the health of those trees, their mineral nutrition. Well, hopefully I'm very confident be able to show that the toxic metals in the ash are not an issue. A new project is looking at bioavailability of calcium in the ash, just to make sure that this then we're on track by recommending a 2-ton dose. And then we've just started work on maple sap production. But my heavens, there's lots we could do, and I've listed it here. If we can fund additional students to look at transpiration, carbon capture, the biodiversity of fauna, let's remember that acid rain affected birds because of calcium loss in watersheds. Calcium limited trees, the wood from calcium limited trees is 30% weaker than the wood from the same species of trees that are not calcium limited. So there's lots we can learn by continuing to work at Camp Big Canoe. So together, I think we can protect our watersheds from ecological osteoporosis. And I'd like to invite you all to join with Doug and me as members of the Friends of the Muskoka Watershed, in addition to members of Camp Big Canoe, as we move forward together to protect the watershed and lake at the camp as a model for how we can protect the rest of Muskoka from the widespread scourge of calcium decline. Thank you very much. And I'd be happy to answer any questions or do whatever you want, Doug, at this point.
That was great, Norman. Does anyone have a question they want to ask? I have one or two, but
or I can answer any questions by email that if Doug passes them to me
later. Yeah, could just speak up. Okay. One of the things, and this is more of this is what I'm thinking versus a question, but on the tent line side of the lake, we've had downbursts in the last couple of years that have ripped the top off of really healthy maple trees. Yep. And they've, fallen mostly just in the forest, but in one case, and no one was there, it was in the spring on one of the tent platforms. So my thought is, can we strengthen those trees on that side by adding wood ash? Because we're looking at ways of strengthening the tent platforms and doing that because we want to stay in the forest.
Okay, so the approval issue is something we'd have to talk about, but it's on private land, which is a big help. So the new wood, we can't strengthen the heartwood of the tree. It's what it is. But the new wood that's being added every year around the outside could be twice as thick and 30% stronger if the trees were not calcium limited. The work done in the Halliburton forest showed within 2 years a doubling in the amount of wood produced. And the literature suggests that that wood would also be stronger because the cells are cemented together by calcium minerals, just as in our bones. So I don't remember as a kid walking through the forest and seeing trees snapped off 30 feet off the ground all the time. But I'm seeing a lot of that now.
Yeah.
And I do believe the most logical explanation for that, other than more violent storms, is that the trees are not as strong as they used to be because they're calcium limited. So,
okay. We have a question that I can't answer because I don't understand it, but do you have any data on the impact to mycelium levels after the ash is applied?
At Hubbard Brook, not here, and we're not looking at that. But there was definitely more fungal growth associated with the roots at Hubbard Brook, and a lot more fine root growth. So I'm not sure why, but yes, I think the answer is calcium limitation is so severe in our forest soils in Muskoka after 70 years of acid rain that everything is somewhat damaged by low calcium. So it'll be good for the mycelia as well.
Can I ask a question or two? It's David Patterson.
Sure.
Just first of all, how about you take it off the share screen? We don't need the question marks so that we can see you. I can't see you right at the moment.
Oh, okay.
But if that
I'll see how to do that.
Anyway, one of the questions I had was, how long does the treatment last? And I've got a couple that I'd like to fire at you if I could. How long does the treatment last? Does this have to be done every year, or what? How much?
No. I'm doing my best to get rid of the shared screen here.
Yeah, you've got it. We can see you now.
Okay.
Yeah.
Yeah.
Okay. Okay. At 2 tons per hectare of ash, which is 30% calcium, would replace all the calcium in the soil lost over the last 150 years. We're not quite sure it's all available yet, which is why we're going for 2 tons. You know, that's a little more than actually would be needed. In Sweden, where they've been doing this for several decades, in heavily managed forests where they cut every tree down, they recommend doing it every 10 years or 20 years. It all depends if you're not logging the forest and removing that pool of calcium, I don't believe you'd have to do it more than once. My friends at Westwind Forest Stewardship suggest it would be nice if you could do something like this every logging cycle, but they're thinking more like gardeners of the forest, you know, that there's always some harvest you want to take out, and you want to make sure you replace the nutrients that were removed in that harvest. So my sense is that this is absolutely not something you have to do every year or even every couple of years. You might want to do it every 20 years or something like that, but it's going to be decades, not years for sure. And if you're not actively logging, you might only have to do it once.
Follow-up question, another question is, how does this work on farmland also? Should you be doing this to farmland?
Everything depends on the sensitivity of the soil and its vulnerability to acid rain. Like across the mixed hardwood forest of central Ontario, this is where it's absolutely worst because the soils are really thin, acid rain rates and deposition rates were really high, and the mixed hardwoods have higher calcium requirements. Farmers have been adding lime for years for a similar reason, to get calcium levels up and the acidity of the soil down. So it all depends how much soil and how much there was and there is, and then how calcium rich that soil was. So it's going to be very much place specific. So if the glaciers were generous enough and you're in an area where they dropped 10 feet of soil instead of the normal 1 foot that Muskoka has, you probably wouldn't need to do this. And you certainly don't need to do it in Southern Ontario. And there are certainly lots of places, and like if I move to Haliburton from Muskoka, there's more variability in soil over there. And so there are areas that need it a lot, just as much as Muskoka, and other areas, especially because there's some Precambrian carbonates in Haliburton that don't need this at all.
And a third question would be, what about the negatives of burning wood? It's obviously creating pollution and such. Is there a balance between the one side and the other?
Yeah, I'm certainly would absolutely not recommend that people start burning just to generate ash that they can use. But if they're already, this is for people that are already burning wood. You know, we're not encouraging a switch to biomass energy just for this purpose. But let's think again to what they do in Scandinavia. It's a completely cyclic economy there. They log their boreal forests. They bring the boles of the trees for timber and pulp. They collect all the slash, and they take that to cogeneration plants and heat the towns. And then they take all the ash from the cogeneration boilers and take it back to the forest. And that's required by law that they do that. So I don't recommend, if you drive through the backwoods of Muskoka and Haliburton and Hastings Highlands, probably a half of all the people that live on roads that don't have gas lines would heat with wood. And so it's those people that are already heating with wood that we're trying to target.
And can you get enough to do the forests of all of Muskoka with that, or?
Not next week. So there's about 300 to 500 tons of ash produced by residential heating in Muskoka every year. So that at 2 tons per hectare, you can do the arithmetic. We'll do 100 hectares or 150 hectares a year, something like that. So this is a long-term project. And that's just the residential wood sources. There are also there are industrial sources that are 10 times bigger. And most of the research that's been done in this area is on industrial wood ash sources. So we stopped, for example, at the Murray Brothers Timber Mill in Madawaska, and they had a boiler just to burn bark that was the size of my house. And so I think they generate as much ash just in that one timber mill as all of Muskoka does. So if we can, to roll this out, I think would take more than residential wood ash, which is fine. But let's remember that it took 70 years to create the problem. And the problem was created by all of the burning of fossil fuels in Eastern North America over the last 70 years. It's a lot to ask that 1,000 residents making pancakes in Muskoka are going to solve this overnight. But we're not going to solve it without them, because it's those 1,000 Muskoka and Haliburton people that are heating their own homes that are going to generate the public will. And I'll tell you now, they already have the will. You know, they're coming out with their cans of ash at minus 25 degrees, driving in one case 6 hours from Manitoulin Island to bring us 3 cans of ash. So the will is, the interest is there. I just think we can't pretend that we're going to solve this overnight. But I think there's no, let me say it another way. Something else I've learned from 50 years of work in the environment, in the environmental science field, is you have to be patient. You know, lakes flush over decades. This problem took my lifespan to create. If we can solve half of it, in the rest of my and my children's lifespan, I'll be content.
Great project. Thanks for the presentation.
Thanks, Dave.
Thanks. Just one last question before we close up here. So for people who want to do this at their own home or their own place, what's the plan for that?
Okay, so first of all, if you want to do it at your own place, it would be nice if it's a hardwood bush. So it's the maples that need it most, the hardwoods need it most. For God's sakes, make sure the ash is cold. And if you want to do it at home, so that's like a week, cool it for a week anyway, if you're going to use it yourself. If you've used any construction waste for kindling or anything like that, you are going to have stuff in that ash that shouldn't be spread back in the forest, staples, nails, screws, hinges, that kind of thing. So if we could encourage you to bring it to us at one of our ash drives, then we will screen it. We'll run huge industrial magnets through it, take all the sharps out. We'll make sure it's cool. We'll analyze it and make sure it's clean, and then we'll give it back to you. The plan is to move from what we're doing now, which is more researchy. You know, we're working just at the camp, to hopefully by next year where we can be essentially certifying the ash for people to take back and use on their own properties where they need it. And then we'll start tracking where it's going and slowly build up this map of a restored Muskoka landscape on homes.
Yeah, thanks, Norm. And I'm excited about this partnership from the camp side, where we have a lot of scientists who are interested in working there, and we have a lot of kids who are coming through who this would be great information for. This fits right into our rediscovery programs, our outdoor skills, those ones. So, and everyone I've talked to, all the Trent students, everyone from any of the universities has said that and anyone who's working for us has said that they're really excited and would really love to get in and share this information with kids. So I think there's a real big opportunity for the camp to learn a lot from this too.
Well, thank you. Thank you very much for the opportunity to speak to you about what we're doing at Camp Big Canoe. and for making Doug's, and for agreeing to make Doug's life even more complicated than I believe it currently is. And so we sure love him on the board of the Friends of the Muskoka Watershed. So thank you all. So I'll
Thank
leave
you.
you now. If you have any other questions, give them to Doug and I'll be happy to answer.
Yeah. This is where I give you the Camp Big Canoe hat or sweatshirt or something if we're
Okay.
in person, but I'll get it to you.
Okay, thanks, Doug. Take care.
And
all.
we will be contributing.